Hi, I'm going to do this video is going to be about material science again. When you solder things, it's like you're hot gluing them together with a lowering melting point metal acting as the glue, but the parts themselves don't melt or change much, and if you do it right, they don't change in their being annealed or tempered, but it depends on the metal. With welding, you melt the parts together and or melt a second metal. Is there something partway between? Yes. Brazing, or hard soldering, is when you do it in such a way that it bonds them to each other, in some cases almost the same way as a welding activity. It has to be, quote-unquote, just below the annealing temperature of the metal to be considered just hard soldering and not welding. But then again, you can also weld and not take out the temper in metals. Depends on the metals. But the thing about this is that when you solder, let's say you're soldering wire for an electronics project together, it's usually copper wire covered with a layer of tin. Tin is an element. The solder is usually tin mixed with something else. And when you have a metal that melts at this temperature, and you mix it with another metal that melts at a different temperature, if they melt with each other, the temperature will drop below, in some cases, depending on which way you do it, below the temperature that they both melt at. And they'll instantly become, when you mix them together, a much lower temperature melting material. Now, this can also make it to where that they're sometimes stronger. If you mix nickel and chromium, you get other characteristics with steels, for instance. So you end up making an alloy. Now, the alloy can also have a characteristic that's called being eutectic. That means that the metal will instantly change from being a liquid to a solid, just like elemental tin or elemental lead or elemental silver. They have a very fast transition, or zero-time transition, depending, from going from a liquid to a solid state. They take up the same amount of volume, usually. But sometimes that also changes. You could mix two metals or two elements together, metallic elements usually, that have very different expansion qualities, and suddenly they'll have a completely unrelated one. And in this way, we make alloys that in some cases have almost no expansion ratio. They literally don't change volume. They're used for rulers and measuring sticks and sometimes high precision equipment. Also, you can mix it together in such a way that you have two or three of them mixed together, dropping the temperature down to nearly, easy bake oven metals. For instance, zinc at a relatively low temperature of 800 degrees Fahrenheit is used to make all sorts of things. It's called pot metal, and it's not required to melt at such a high temperature like aluminum. What can you join together when you solder things? Depending on the metal and the two objects you're mixing together, and they can be different metals, you can use this to solder together silver, gold, nickel, silver, tin, silver, copper, cast iron, stainless steel, mild steel, carbon steel, spring steel, manganese steel, chrome manganese, chromoly steel, carbon moly, galvanized iron, cadmium-coated steel, German steel, whatever the heck that is, and other mixes that melt at a higher temperature like brass bronze, white bronze, inconel, I forget what that is, copper nickel mix, and silicon bronze. Now let's go on. Temperature versus maximum strength, depending on how you measure it, versus silver mixture versus the tin for silver solders and others. Let's start at the top temperature. This is traditionally called silver soldering. 70,000 psi, depending on what type you get. 56% silver, the rest is tin, is usually called hard solder, and it's very close to brazing temperature. Brazing rods, if you know about doing this with a blowtorch, I did this when I was in high school and also in college, you are melting brass or bronze metals. These are, again, metals that are mixed together from two elements or more. They mix together and they have a lower melting point. And they can also be very, very strong. In this case, you're using silver, which seems to be a fairly soft material, but the tin-silver mix makes it to where you can hold together things like iron, all sorts of those metals. Almost all of those metals can be done with silver solder. But it requires 1100 degrees Fahrenheit or thereabouts, depending on the ratios. What about other ratios? Well, below 56%, it has undesirable characteristics like staying soft too long or not long enough, depending. What about pure silver? Well, it melts at pure tin. It melts at a specific temperature and becomes a specific strength, blah, blah, blah. It's going to be a different temperature. But what about other mixes? Well, plumber's solder contains antimony, 5%, and then the rest is tin. And it has a strength level of, instead of 70,000 psi, it has 5,000 psi. But it melts at 464 degrees Fahrenheit, so metals that are sensitive to heat, you can do that with. Just above that, you can do 7% silver and tin mix and get 31,000 psi. But it's 570 degrees Fahrenheit. But it's only 7% silver, excuse me. What about 3.5% silver? That's exactly half the ratio. It gives you 25,000 psi, and it'll work at 430 degrees Fahrenheit. Yeah, it's lower than that 7% tin silver mix, but it's almost the same strength. But it has no copper in it. A lot of them have copper mixed in. And you can also get it to where it acts in a eutectic way, depending on the ratio. It'll literally go from being a solid to a liquid and back again rapidly. It doesn't have a temperature range. It's exactly a specific melting point. Then you can have just below that, at 428 degrees Fahrenheit, 21,000 psi, 3% silver, just below the 3.5% mark, silver, then tin, and then 0.5% copper. Now it's spelled out as SAC, but I like using another one, CUSNAG, CUSNAG. It's for electronic solder. It's what I use for binding my glasses together. It's essentially silver solder, but it's the wrong ratio by a tiny amount. But if there's any silver in the metal, it'll leach the silver out and become literally the eutectic no copper version of it, because the copper alloys back out, sort of. Then there's even lower temperature, lead alloy electronic solder that's 63% tin and 37% lead. And this melts at 361 degrees Fahrenheit and goes back down to 5,000 psi. Now, some of these will say 5,000 psi, but the ratio is actually 10 to 1 and they're 50,000 or something like that. This isn't one of those cases. Lead solder is very soft, but the partial silver tin mix solder is fairly tough, but not its mechanical strength or even tensile strength, but binding strength like a glue. That's why silver is used. Silver has an affinity for bonding on a chemical level, and if you give it very little space and coat the metal objects you're soldering together or brazing together, if you can get that material in there, it'll bond tighter, so tight that it's really difficult to take them apart. This is, if you were looking at this video, this is part of the requirement for modifying, let's say, a gun or some equipment requires this level of soldering, and they require specific temperatures. They want 1100 degrees Fahrenheit. But if you're willing to literally make it half as tough or do a really good fitment on the equipment, you can get close to the same PSI rating and only have to use half the temperature, or in some cases, even less. So where is this coming from and where does this go? Well, some of these pressure levels are based on only soldering together copper, but some of them are based on soldering water pipe. And because it's based on shearing strength, them going past each other, you can build up layers of metal and bond them this way and make them indistinguishable, and it will qualify if it is high silver content. It only has to be 7% or 3.5%, depending on what you're doing. You can get away with doing this by coating it with something called tinning flux. There are tinning fluxes for water pipe, and they're based on antimony, but you can also, because it's better for the water quality, they sell cheaply because they want to make sure people use it more. If you're doing water pipes, you can find ones that are silver-bearing tinning flux. So you paint the pipes. It doesn't matter if it's steel, because it has silver-based material in it. And if it has no copper in it, it'll transition from being a liquid to a liquid again, or solid, liquid, solid, at exactly, let's say, 430 degrees Fahrenheit or whatever. It'll say right on it. It may even say the word eutectic. But it's subsidized because your local state will want to use that for water pipes to keep the lead from happening, because people will be tempted to use lead. And antimony also has some problems with it, so this is safer. And you may have the ability to bind together metal pipes and parts that way without welding them and without taking out the temper, which means you can reuse parts and repair them by sleeving methods. If you only care about the interior diameter staying the same, you can sheath on the outside, or the entire length of a piece of metal tubing, or several pieces that you stuck together because you need to make a size change and you don't want to sit there with a freaking bore or a ream to do so. Therefore, you can make your airsoft gun out of pieces, line them upright, and then do very little milling afterwards. Or you could use it for something like a water sprayer. See also hydraulic grade metal tubing that's made tempered for it, which would work very well for a lot of things. Next, we go on to the next. And yes, I looked this up on a forum for people trying to repair AR-15s because gas tubes blow up. Because idiots. So anyway, here we go. Update on the Hatfield, aka Walmart, $100 single shot break action folding shotgun that you can buy. Anywhere from $110 to $140 now. Don't buy it for more than that. I have Hatfield Gun Company itself sells them, $140. Scott's Outdoors also has them available. But which ones? The 410, the 12 gauge, or 20 gauge? Yes. All of them. Sitting there. All three on both sites. Because Scott's Outdoors gets a bulk purchase every once in a while and sells them. Now, why would I bring this up on my channel? Because this is, again, the same. Because Walmart decided to stop carrying these or even telling you that they have them because they're afraid of backlash or whatever, or they got rid of the guns. If you're thinking of making a gun, think, is my life worth saving $110? It used to be $100, now it's $110. Yeah, the Flaringer, when your life is only worth, literally, $100. Next, I'm bringing up a list of stuff I looked up. The 50 caliber rifle barrel pistol limit versus 50 caliber shotgun, which doesn't exist but should, and rifle, using one ammunition type that will work in all guns to be bestest gun ever. And all you have to do is gauge, literally, how much energy you want to have it do by having just different amounts of grain weight for the propellant and for the projectile. The goofiest things I've seen so far. Beowulf pistol, based on the Han Solo inspired 300 pistol prototype. You can look at a couple of videos. The Beowulf cartridge is a kind of cartridge you can get a hold of that's up near 50 caliber. You can also convert any Glock to something that doesn't suck ass like it normally does and make it a 50 caliber by just changing the upper parts, because we serialize only the lower, for $600. You can do a 50 caliber insert for 12 gauge for $5 from the hardware store by using Schedule 40 and Schedule 10 pipe, or just use a Schedule 160 0.464 inch inner diameter, half-inch Schedule 160 pipe, and then making it work, and then thermal treating it and case hardening it after you rifle it, the whole barrel. And then you then chamber it. Not saying you could sleeve chamber any of this, or lock chamber, for any of these pistol, quote-unquote, and rifle, quote-unquote, cartridges. And again, legally, all you have to do is make it ATF legal, and most states don't have a problem with it. Void where prohibited, aka California. Next, other cartridges. I mentioned it in another video, but here we go. The 500 caliber Magnum Nitro Express has a rimmed cartridge, or not. The 500 Smith & Wesson Magnum rimmed cartridge, because it is easy to do a gauge and bore if they're the same. It's a lot easier to work with a rimmed cartridge as far as project, or an insert for a standard 12 gauge you can get for $100 and some odd. 44 Marlin. For when your 410 shotgun isn't scary enough, you can stick this holy shit cartridge into it and fire it. Or just use a 44 Magnum where you should be using a 45. Again, you can do these things. You can also buy them. And again, is your life worth saving money by not buying something that is guaranteed to work that was made by a company that makes them? And it's just a piece of metal. It doesn't require any shipping rules or laws. It's a gun component, but if it's an insert, it's literally not. Cases type that are rimmed and straight, listed. Straight wall cartridge list below. And then finally, maximum pressure levels for these versus soldering weights. Information dumped. Do with it what you will. I'm not responsible for your actions. I don't want to be. Thanks for watching. Have a good day.